Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my wonderful students. Today you see me with a calculator. I hope you have your calculator, students of Senior 1, because today's lesson is a bit special because of the complaints and challenges I know students are going through, especially you students of Senior 1. I am Teacher JB, your physics teacher, and today, before we look at another unit, I want us to review Unit 4 and Unit 5, especially areas that require us to use calculators. There are questions that we have been looking at. You know, if you remember when you are looking at Newton's laws of motion, especially law of gravitation, we looked at very small figures and very big figures, and some people have a big problem pressing those figures on a calculator. So I want us to move slowly during these 30 minutes so that we can rectify that problem, okay? So I have combined some questions from Unit 4 and Unit 5, which is what we want to look at. Otherwise, this would be our lesson number 4. Okay? So have your calculator, have your notebook, so that you are ready for the lesson. And I am expecting you have got a scientific calculator. You are not having a calculator with very few functions. You are having a calculator with more functions. Okay. Now, before we come to the calculator, I want to take you to the previous assignment that we had, because I don't want to continue when that assignment is hanging. I want us to first, finish it up before we move to something else. So, very quickly, we are going to answer those questions. Part A, what is the stability of a body? I remember we talked about this, right? What is stability of a body? We said stability of a body is the state of a body to remain in equilibrium even when slightly pulled or pushed. That one we talked about, we don't need to explain it again. When a body remains stable in equilibrium, when it is pushed or it is pulled slightly, then we say the body is stable. Okay, let's look at B. Name the 3 states of equilibrium. Name the 3 states of equilibrium. Again, this is walkover, very easy. We looked at that. We have, okay, let's begin with it. Stable equilibrium. That is one. The other one is unstable equilibrium. And the last one is what? Neutral equilibrium. Very good. Some of you have got the answers very nicely. Good physics students, neutral equilibrium. And today we are not going to explain what they are because we have already looked at them. Then part C, explain why overloading is dangerous to passengers. I think you remember we looked at overloading. When you are carrying, like a car is carrying more luggage than it is supposed to, then we say it is overloaded. If you remember last time, I showed you there was a car which had a truck which had so many people. Do you remember? There was even a bus where some people were sitting on top. So many people sitting on top of the bus. Can you imagine that? Of course, you can't see that here in Rwanda, but maybe in some other places it is there. That is dangerous. So why is overloading dangerous? So overloading is dangerous because what does it do? It increases or raises the center of what? Of gravity of the car. And when it raises the center of gravity of the car, then it makes the car very unstable. Remember last time we said, for tall people like us, me, I'm very tall, we are less stable, especially when we are walking. If it is a slippery ground, we can easily fall. But for something short, okay, like this tool is more stable than I am if we had the same properties. So overloading increases the center of gravity, and that makes the car to become very unstable. Part D, explain why it is safer to load a bus with the luggage in the boot rather than on the top. You see, part D. This is connecting to what we have just said here. If you look at a bus, we put luggage in the boot. Why? So luggage is put in the boot of a bus in order to do what? In order to lower the center of gravity and make the bus more beautiful? No. And make the bus more stable so that the bus does not topple over. So that's why we put luggage in the boot. Go to part E. Why is it not advisable for passengers in the upper deck of a double-decker bus to stand while the bus is moving? Now, part E, I guess, is now easy. In a double-decker bus, remember we said passengers should not stand, those ones who are on the upper decker. Because if they stand, they will increase the center of gravity. They will raise the center of gravity and make the bus less stable. So that one, even if I don't write it, I think it is easy. Don't stand when you are in the upper decker of a bus, because if you do that, you are going to increase the center of gravity of the bus, and then you make the bus to become less stable when it is tall, okay? Then F, it is less likely for a short person to fall on a slippery ground compared to a tall person. I like that one. That's very true. Also, that is in relation to center of gravity. So a short person has a lower center of what? Of gravity. Okay? A short person has a lower center of gravity and is more what? More stable. Because we said stability depends on the center of gravity. Okay, so I hope that is fine. Let's look at question 1, because that was previously. So question 1, which is on the screen, I hope you can read with me. The car aside, that car there, it hadn't yet come, now it is there. The car aside is accelerating around a bend on a road. You see, when you're moving on a road, you find there's a bend. So the car is accelerating. Mark that word, accelerating. The speed limit on this segment of the road is 40 kilometers per hour. Okay. So they are telling us of a speed limit. When they talk of speed limit, it means you are not supposed to drive beyond 40 kilometers per hour, because that's the speed limit. You don't exceed that. Let's go ahead. The instant the car was photographed, you can see that photo. Okay? That's the car. I hope you can see it. So the instant this car was photographed, it was moving at a speed of 20 meters per second. Okay? So the current speed of the car is 20 meters per second. And remember, this can be written as 20 ms to power negative 1. We talked about that before. Part A, the car is accelerating, in quotes. What is the meaning of this statement? So let us answer part A. When they say the car is accelerating, what does it mean? This one means that the car is speeding up. The car is speeding up. When I say it is speeding up, it means the car is moving faster and faster every second. In other words, someone can say the speed of the car is increasing. Okay? The speed of the car is increasing. That's the meaning of that statement. Let's go to B. Does the car exceed the set speed limit? Of course, if this person who is driving, the driver, keeps on increasing the speed of the car, he might exceed the speed limit. But now let us see whether he has exceeded the speed limit. Remember, the speed limit is 40 kilometers per hour. But right now he's driving at 20 meters per second. So we need to change 40 kilometers per hour into meters per second. That's what we need to do. So let us see how we change that. It becomes 40 kilometers divided by 1 hour. This is how we change. 40 kilometers per hour, this is the meaning. So change 40 into meters. So we multiply that by 1,000. Then also change 1 hour into seconds. So we shall have 1 hour. If I change, how many minutes are there in 1 hour? There are 60. And how many seconds are there in 1 minute? There are 60 seconds. So it means we shall 1 hour, when you change into seconds, we multiply by 60 and another 60. So this is going to give you 40,000 divided by 3,600. Remember, this is meters and that is second. So let us see what we get. Remember, I told you to get your calculator, so you have your calculator. Press along with me. Okay, 40,000, then divide by 3,600. For me here, I'm getting 11.1 recurring. Okay, 0.1 recurring. And this can be approximated to 11. If I want I want a whole number, so it is going to be 11, and the unit is going to be meters divided by a second, which is meters per second. So look at the driver's speed right now. The speed limit is 40 kilometers per hour, but 40 kilometers per hour is 11 meters per second. This driver is now at a speed of 20 meters per second. So the question is, does the car exceed the set limit? Of course, your answer is going to be yes. The car has exceeded the set limit. That is what has happened. The car has now exceeded the set limit. And is that dangerous? Yes, very dangerous. When they tell you the speed limit is 11 meters per second, and you go to 20 meters per second, you are likely to cause an accident, and that is dangerous. Never exceed the set limit of speed along a road, because it is dangerous. Okay, we go to C. Does this car overturn? Does this car overturn? Okay, now for the car to overturn, just look at the diagram. There's a line here coming from the center of gravity. I think you can see a vertical line coming down. Look at the base of support. The base of support is the distance between these two tires. So as you can see, the car has already tilted like this, and that line is outside the base. So our answer to part C is yes. The car does what? The car overturns. Another word we can use for overturning is the car topples over. Okay? How do you know? Yes. This is how we know. Because the line, oh, sorry, let me use the word vertical. How do I know that the car turns? It is because the vertical line from its center of gravity is outside the what? The base of support. That is how I know that the car overturns. And remember, we said one of the reasons as to why a car overturns is when that line goes outside the base of support. Then we go to D. What does D say? Why is it good to have speed limits on the roads? There are many reasons. Hope you can see. We have just talked about it. One of them is to reduce, which is the most important one, is to reduce road what? Is to reduce road carnage, road accidents. Because if you have accidents on the road, I don't think it is good to anybody. It is bad because it destroys people's cars, but most importantly, it destroys human life. It can kill you, it can harm you, and then you get maimed. So that is bad. Right. Let's go to another question, which I hope you can read from the board, from the screen. So you have got question number 2. State Newton's universal law of gravitation. This is something we looked at, and I want to believe you still remember, but let me try to state it for you. Newton's law of universal gravitation states that the force between any two bodies is directly proportional to the, I hope you remember, to the product of their what? Of their masses. But inversely proportional to the square of the distance between them. Okay? That's what we said. We mentioned that very many times, that the force between any two bodies is directly proportional to the product of their masses, but inversely proportional to the square of the distance between them. That is Newton's law of gravitation. And if you remember, we got a very beautiful formula from it, where we said F is equal to G m1 m2 then over r squared. Some people, instead of using R, use D. You remember that formula? Very nice. That's what we looked at. Where G is universal gravitational constant, F is the force, M is mass. Okay, M1 and M2 are masses of the two bodies, and R is the distance between the two bodies. Okay, in part B, which is where my main focus is. In part B, they are saying Kaiser is 28 kilograms. So we have two people. That is part B. Kaiser. Okay? Let me put this as Kaiser. That is our Kaiser. And there's another one called Mukisa. So let me put Mukisa here. So what are they telling us? Kaiser is 28 kilograms. So M1 is equal to 28 kilograms. This is Kaiser, remember. And this is Mukisa. and is standing 1.2 meters away from Mukisa. So the average distance between them is 1.2 meters. According to me, it tells me that R is 1.2 meters. Okay? What is the mass of Mukisa? They want mass of Mukisa. So let Mukisa's mass be M what? M2, because M1 is for Keza. So we shall be looking for M2. If the gravitational force of attraction, they have given us the gravitational force of attraction, which is F, is 3.2 times 10 to power negative 8 newtons. This is where the problem comes from. Pressing that has been a problem to us. And also they have given us G, universal gravitational constant, as being 6.67 times 10 to power negative 11. I hope you can see on your screen, it is right there. So Newton meter squared per kilogram squared. Remember, we looked at all this, how to get G. My major focus is how to press this on a calculator. That's my major focus. Good. So get your calculator. The challenge we have is, how do we press figures like this? But you should also remember, if I have 0.02, this I can write in standard form, which is the same as 2 times 10 to power negative 2. Because here we move 1 step, 2 steps to the right. So it becomes 2 times 10 to power negative 2. And by the way, if you didn't know, but of course I know you covered this. This is the same as 2, then divide it by 100, which is the same as 2 out of 10 to power 2. Now in mathematics, this becomes 2 times 10 to power negative 2. So the question is, how do we press these values on our calculator? Okay, this is what we do. I want you to look for a button which is written on this. Can you find it on your calculator? Mine is right here. Exponent. Mine is right here. Also, find a button which is written on, like on my calculator, it is this. I hope you will find it there. That is where you get negative from. Okay? So let us press our calculator and see what answers we shall get. So the equation says F is equal to G M1 M2 out of R squared. Now we want to make M2 the subject. So if you cross multiply, we shall have G M1 M2 is equal to F R squared. Okay? Now make M2 the subject. We divide this side by G M1, divide this side also by G M1. I hope you are following, students of senior 1. Okay? So this will cross that, you remain with M2. That means M2 is equal to F R squared over G M1. Okay, that is where the thing is. Allow me to wrap this off. I'm just going to write on the upper side. I hope you will be able to see that. Okay, so we are interested in getting M2. So M2 is going to be equal to F. F is the force, which is 3.2 times 10 to power negative 8. Then times R squared. But what is our R? R is 1.2. Remember, 1.2 is R, so we have R squared. Okay? That is this, FR squared. Divided by G. Divided by G. Now, what is our G? 6.67 times 10 to power negative 11. That is G. Then times M1. And what is M1? M1 is given as 28. Very good. So when students see this, people fear because of the figures. When you have this weapon, you shouldn't fear, especially if you know how to use it. And that's why we are here. We want to learn how to use it. So you're going to press this with me. Are you ready? We have little time, so we try to hurry up. So you're going to press 3.2. Now we want to press times 10 to power negative 8. Now, times 10, this one exponent. This one already means times 10. The moment you press exponent, it means you have already pressed times 10. So we have pressed 3.2. Times 10 to power negative 8, I'm going to press exponent. Letter E appears on the screen, as you can see. Then to power negative 8. Now to power negative 8, I press this. You remember this button I told you about? I press this, minus 8. So that's what I've pressed, which is here on my calculator, times 1.2. But 1.2 is squared. Then there's a button which has x squared, this one. So I square it. You can even press equals, no problem. Then you divide. Now here I have two terms. So what I do, I open the bracket, because there are two terms here. So I have 6.67 times 10 to power negative 11. Again, I'm going to write exponent, then negative 11, then times 28, times 28. Then close your bracket, equals. So what answer do I find here? I find 24.67. And this is M2. That means the mass is going to be in kilograms. And that is whose mass? Mukisa's mass. So that was the gist of our lesson today. Allowing you, making you to be able to press your calculator and be able to deal with figures like this one. Because students were getting problems with that. Okay? So I hope you are going to do more practice on more numbers so that you are very competent in handling that. So let me leave you with just one question as we end our lesson. I leave you with one question which will require you to use your calculator, pressing numbers with exponents and pressing smaller numbers or even bigger numbers. I know if you do practice, you should be very okay. So thank you so much for being wonderful students. And I know you have been taking notes, you have corrected yourselves. Do practice, then you can be better. Stay safe till we meet again next time. Bye-bye.